Oh, welcome to this webinar today. I'm gonna share my screen. Can you all see the slides?
Yeah, it's showing us your presenter view, just so you know.
Yeah.
So we can see.
Oh, it's got,
Yeah.
okay. It's got the other view over here on my other screen. Let me see.
If you just reshare, and then it should let you reshare the screen that has the full screen on it.
Let me try. Okay, now, all right. Great. So today we have a panel discussion on co-requisite support for introductory statistics. I am super excited about this. This is sponsored by the ASA's section on statistics and data science education. Here is an outline of what we're going to do today. We'll have some brief presentations by our panelists, and then we'll have some Q&A. And the audience will have some time to ask questions. And the first thing I'm going to do is tell you just a little bit about our panelists. Roxy Peck is Professor Emerita of Statistics at Cal Poly. She was a faculty member of the Statistics Department for 30 years, serving for 6 years as chair of the Statistics Department and 13 years as Associate Dean of the College of Science and Mathematics. Nationally known in the area of statistics education, Roxy was made a fellow of the American Statistical Association in 1998, and in 2003, she received the American Statistical Association's Founders Award in recognition of her contributions to K through 12 and undergraduate statistics education. In 2009, she received the USCOTS, or USCOTS if you prefer, Lifetime Achievement Award in Statistics Education. Next, we have Rebecca Wong. Rebecca has been an educator for over 40 years with degrees in mathematics from UC Santa Barbara and Santa Clara University, and a doctoral degree in educational leadership from San Francisco State University. Rebecca has devoted her career to improving student access to higher education. Recently retired from West Valley College, she is currently an adjunct professor at the University of San Francisco. Next is Alana Unfried. Alana is an associate professor of statistics at California State University, Monterey Bay. She received her PhD in statistics from North Carolina State University. She also enjoys collaborating with STEM and education faculty on studying K through 12 student attitudes towards STEM. Outside of work, Alana spends most of her time chasing after her children, ideally outside while on a hike. She's also an avid reader and dabbles in playing the piano. And I'm just realizing how California heavy we are today. California is well represented. And then we have Margaret Wood. Margaret earned her PhD in anthropology and is the Associate Vice Chancellor for Academic Achievement and Professor of Anthropology at University of Colorado, Denver. She leads programs from orientation through graduation, which helps students establish a sense of belonging, participate in high-impact experiential learning, and achieve their academic goals. Before coming to CU Denver, she earned the rank of full professor at Washburn University, where she was the founding director of the Center for Excellence in Teaching and Learning. Okay, so Roxy will start things off now.
All right. All right, so actually, I got to hit one slide ahead of myself. I'm going to start by just making sure we're all on the same page in terms of what co-requisite support is. So co-requisite support is where students who have been assessed as being underprepared for college level work get extra support while they take the college level introductory statistics course, instead of putting them into the traditional path of putting them into remediation, where they have to remediate in mathematics before they're allowed to take a college level mathematics course. And, a little bit of history here. The theory for years and years and years, we bought into this theory behind traditional remediation, and that was that if students weren't prepared for college level work, that they should be enrolled in one or more, a series of remedial classes, because that would put them on an equal footing with students when they got to the college level course, when they all take these college level courses together. But depending on, excuse me, depending on placement policies, sometimes this puts students in 4 semesters of remedial work in mathematics, where they had to remediate all of high school mathematics. It's not that they hadn't seen these things, but often it's because they just didn't place well enough on kind of an arbitrary placement exam. And it's been reported, it varies from year to year, but it's been reported that as many as 68% of new freshmen at community colleges, public community colleges, and up to 40% in public four-year colleges. And again, this may be higher or lower depending on your particular location. But those high percentages are placed in at least one remedial course. But there was no evidence that the students assigned to remediation ever came out the other end of that, what is sometimes a long pipeline. And as people started looking at the data on that, they discovered it wasn't because necessarily that they were failing the remedial courses. It was that it just presented too big of an obstacle. So they were dropping out somewhere along the way. Not even having failed the most recent of the remedial courses that they'd taken. It just was an obstacle that prevented them from achieving their goals. And so people really began to question the value of traditional remedial mathematics. And so as a result of that, and this kind of accumulating evidence that supported that co-requisite remediation was actually a more effective way of helping students be successful in those introductory mathematics courses and in their progress toward a degree or whatever their educational goals might be. And I've given a reference here, and I have some references listed at the end of the slide as well, because we have very limited time. But one example I thought that does a good job of making the case is this extensive evidence of co-requisites remediation effectiveness. And so I encourage you to take a look if you still have questions about the effectiveness. Just a little bit about models for co-requisite support courses. There are 2 common models and one that's not as common. The one is the commingled model. And in a commingled co-requisite, college-ready and underprepared students are in the same section of the introductory statistics course, but the underprepared students receive additional support through a course that's taken alongside of the college level course that provides support that helps them be successful in that introductory statistics course. That support can involve a lot of things, and we'll talk a little bit about what that involves later. The advantage to that kind of model is that the people that like that model believe that it fosters a feeling of inclusion and belonging in the college experience. Sometimes students that are shuffled into remedial work get a mixed message of, they get their letter, welcome to college, you've been accepted to college, congratulations. And the next day they get something that says, but by the way, we don't think you're ready for college level work, so you have to do all this other stuff before. So it sends them almost the message that, yeah, we're letting you in, but we don't really expect you to be successful. And so this really kind of takes that away. They're not stigmatized in that way. The disadvantages are really logistics. It's a lot more difficult to schedule if you're trying to match instructors for the co-requisite piece and the regular piece. That can be, that can present logistical difficulties. The second model is a cohort model, and this is where students assessed as underprepared are placed in their own sections. There's still the college level statistics course, but they're separate sections that are designated as for students that are assessed as underprepared, and those sections receive additional support. The advantage of that, it's a lot easier to administer, but one difficulty is that, for instance, if your institution offers 6 sections of introductory statistics, and you designate 3 of them as for the underprepared students and 3 of them for the students that are placed it just directly in. It really limits scheduling opportunities for students. Students now don't have as much choice in putting their schedules together. And then there's also this stretch model. It's not as common as the other 2, and this is where they just add more time to introductory statistics. It's kind of the model that Statway, when it first came out, followed. And sometimes taught over 2 semesters rather than a single semester. And so you occasionally will see that model. Like I said, the Statway is one example of that. So the question that people have is, does it work? I've already said there's accumulating evidence, but a lot of the skeptics say, yeah, but what's going to happen? What are we doing to these students? And a lot of the skeptics picked at a lot of the earlier studies and said, yeah, they're observational studies. You can't really, we're statisticians, and we have a gold standard of what we want to see in study design. And so one of and I think maybe 2016 it was. The City University of New York set out to kind of do a study that might satisfy these skeptics. And they actually did a randomized controlled experiment where 907 students, all of whom had been assessed as needing remedial mathematics, but who did not need college algebra for their intended major. So their math requirement was either a general quantitative reasoning requirement or statistics. And they randomly assigned these students to one of 3 courses. One got the traditional remediation, elementary algebra. One got the traditional remediation, elementary algebra, but they put a workshop, a support course with that to help them get through the elementary algebra course. And the others went directly into college level statistics with an associated support course that did the Corequisite remediation. And the references here, it's also in the references at the end. And I think these slides will be provided to you afterwards if you want, so you don't have to get all this down if you want to look at the references. And what they found is the students who were enrolled directly in statistics with the support passed statistics at a significantly higher rate than the students in the elementary algebra or even the elementary algebra with support passed their courses. And that higher pass rate was seen across. They did all kinds of different fancy analyses. You can see those in the paper. It was across colleges, across instructors. They saw the same results. And they followed those students for a year after. And they found that the statistics, the ones that went directly into statistics with support, had satisfied the same number of general education science requirements and had continued to accumulate more credits than the students in either of those other 2 groups. And so their conclusion was that if students assessed as needing elementary algebra don't need to go through that traditional remediation in order to pass a college level statistics course and be successful, as long as they're provided with this additional support in that introductory statistics course. But the skeptics still said, yeah, but yeah, they passed the statistics class, but are they going to get through their science courses? Are they going to get through economics? All these other things that we think they need that math for. And somehow we think that they can't access that content unless they know how to factor trinomials and the other things that we put into that traditional remediation. And so they followed the students. They did a follow-on experiment where they followed these students for 3 years and basically found that they were making actually that they were doing their science requirements with a success rate that was comparable to the other students who had managed to make it through the full remediation. And they were able to get through their college level quantitative reasoning requirement in 2.6 semesters as opposed to 5.2 semesters for the other the other students. And surprisingly, they looked at the students, even though it wasn't required. Some of the students in this study took higher level math courses. They kind of got their confidence up and they took higher level math courses. And the statistics students had actually taken and passed a higher number of the advanced math courses than the ones that did traditional remediation. You know, hopefully some of this calms the nerves of skeptics, but it's still surprising to me that we haven't seen more of this. All of this evidence has led people to think about how to, you know, what their path forward should be. And it's led to things like AMATIC, which is the American Mathematical Association of Two-Year Colleges, actually has now come up with a statement that you see on the screen. I won't read it to you, but you can read if you want to read the highlighted parts in red. Have come out with statements really supporting the use of co-requisite courses and encouraging institutions of higher education to implement these co-requisite courses. So what should be in a co-requisite supports course? Well, I'm going to let a lot of this go to the other panelists, but I just want to say something about, obviously, one of the supports is the remediation of the relevant mathematics. And by relevant mathematics, I mean the mathematics that's necessary for success in introductory statistics courses. And when we work with people that are implementing co-requisite courses, we often recommend this document, the Mathematical Foundations for Success in Introductory Statistics, which you can find on the Dana Center website. This is a document that was written by Rob Gould, Jessica Utz, and myself, where we detailed what are those mathematical the things that students need to know from mathematics to be successful in introductory statistics courses. And we gave ourselves the challenge of, you're not allowed to put your favorite math stuff on the list, which is often a temptation. You can only put it on the list if you can say they need to know this in order to be able to do this in the statistics course. We were quite happy with that document. And we often have people back map the math content for the co-requisite course from this document. I've got a couple of pages here of references. Like I said, you'll be able to get the slides after this webinar is over. I just wanted you to have the links to some of these resources. And now I'm going to pass it off to the other panelists, where you're going to see 2 examples of successful implementations, and also a panelist who really can speak to what it takes to support students for success in these kinds of classes. And I'll comment, the reason that California that we're California heavy on this panel is that California was one of the first states to act legislatively, and it's been now about 10 years where it's been mandated that you have to go this route as opposed to traditional. And so the speakers that you'll hear have had probably a longer time experimenting with this than others. So anyway, thank you. And I'm going to turn it over next to Rebecca. Are you next? Yeah, so I'll turn it over to Rebecca.
Rebecca, you're still on mute.
Thank you. What Zoom webinar experience would be complete without hearing that at least one time? Okay. So Roxy mentioned that there are 2 models for this co-requisite support, the cohort model and the commingled model. So I'm going to talk about the cohort model, and you'll be able to hear about the commingled model with our next speaker. Also, I'm at a 2-year college, and so you'll be able to hear about our experience, and you'll be able to hear about the experience from a 4-year college from our next speaker as well. So I was at West Valley College, which is a 2-year college in Silicon Valley. And we have an introductory statistics course, Math 10, which is a 4-unit course. And when we added the co-requisite support, we wrote a new course, Math 10C, which is 1.5 units. And we support about 10% of our offerings with the co-requisite class as well. So why did we move to a co-req model? We wanted to support student completion of transfer level math courses within 1 year of enrollment. And we'll talk at the end of my slides about, the why that's an important thing. But I think Roxy already talked about that. The evidence is that if students complete a transfer level math course within 1 year of enrollment, they're much more likely from a two-year college to transfer and also to complete their 4-year degree. So one of Roxy's slides talked about one of the not concerns, but things to think about if you have a cohort model. And one of the concerns is students may feel singled out, like as they were put into this particular co-requisite support as not being ready to do college level math. So what we did is our students are enrolled in co-requisite support either because the counselor recommended it or they self-placed in it. So no student is assigned to this course without their own choice. Students have the same instructor for both courses. So it's not like you have an intro stats course and a support class instructor. It's the same instructor for both courses. The courses meet 4 days a week, and there's no delineation between the courses. So if you're in Math 10, Math 10C, your statistics course is just a little longer than the statistics course in the classroom next door. So there's really no other delineation. This cut down on our issues with faculty scheduling their own schedules and also with student schedules. This just made it really easy to put this into a block of time, which is already in the course blocks of time at our institution. And it made it really easy for both faculty to elect to teach these courses and students to elect to take the courses. And so this is our course description that's in the catalog, but I just want to point out that, this course provides students with just-in-time support of mathematical tools needed to be successful in statistics. Actually, this webinar, I think, came about because of a conversation some of us were having in another ASA group working on the GAZE guidelines. We were talking about these co-req supports classes and what should go into them. Should these co-requisite courses be our last chance to give them all of the mathematical skills? Or when they pass statistics, are we verifying that, yes, they have quantitative reasoning skills in general? And our answer to that is no. The purpose of this course is simply to support their success in statistics. And that's what we really focus on, that just-in-time support. Not all of arithmetic, not all of algebra, just the skills needed to be successful in this particular course. So this is our course level student learning outcome. Again, just to synthesize all those other skills that are leading to success in elementary statistics. And that's really our focus and our only focus. So is this working now that we've been at it for 10 years? So like Roxy mentioned, we're California heavy in this webinar because we mandated this with something called AB 705 about 10 years ago. And AB 705 said that colleges were required to make sure that students had access to transfer level math classes within 1 year of enrollment. And essentially what that meant is we had to eliminate our traditional assessment process. And so students could self-place or replace based on their high school transcripts. And so what has happened over 10 years? So this is data from a very recently published study by the Public Policy Institute of California on what's gone on since AB 705 modifications were put into place. So we can see on this slide that it's eliminated the racial equality gaps in direct enrollment in transfer level math classes. So you can see the equality gaps, access gaps in 2015, and you can see that they've been eliminated by now because now all students have access to direct placement into college level math. It's also increased the completion time. So this is completion data by race, disaggregated by race. And so the shares of Latino and Black students who have completed college level math in California in one semester have tripled with these new guidelines. So you can just see the increase, but not just for those groups, for all groups. And why does this matter? Well, like Roxy said, this is an indicator of how likely a student is to transfer and how likely they are to complete their 4-year degree as well. So you can see here The top graph are the math completers and the bottom are the math non-completers, meaning completed within the first year of their studies. So now that we have more students completing transfer level math in their first year of college, disaggregated by race, we can see that more students are transferring. The total transfer rate went from 10% to 43%. So that's just the total, and you can see it disaggregated by race. And so what motivated this change was to improve our through rate, so that Roxy said it was like this tunnel or that they ended up in. People sometimes called it a black hole instead. It wasn't a pipeline because the pipe never went anywhere. They never got to their final destination. But now with these new reforms, we're finding that with these co-requisite supports, we're able to get more students completing math within their first year. And then these indicators just leading to more positive outcomes in terms of transfer and overall completion as well. So that's been our story at West Valley. It's typical, I think, of the story at many two-year colleges in California. And I'm going to turn it over to our next speaker, who will tell you about the 4-year experience with the commingled model.
All right, thanks everyone. I'm Alana Unfried. I'm at Cal State Monterey Bay, and I'm going to talk to you a little bit about our model, a different model, the commingled perspective. So at Cal State Monterey Bay, we traditionally had 40% of our students begin remediation, like Roxy mentioned, is common for 4-year colleges. And also, as we mentioned, historically, we were mandated by our chancellor's office in fall 2017 to move beyond a remedial model, and we were given 1-year implementation, and we were only allowed a maximum of 1 unit non-credit bearing to kind of developmental math in the structure of a co-requisite. So for us, just like Roxy mentioned, we framed this from an equity perspective that we really wanted to have that inclusion aspect of students feeling like they were in the main course, where we're mixing together what we might call college ready or underprepared students into the same class. And then our underprepared students enroll in a separate co-requisite course, but this comes with its own challenges, as we'll discuss. So what this looks like for us is 1 unit of non-college credit bearing work, and it's a separate 2-hour activity period is how we can implement it within the CSU. It's taught by an Introstat faculty member typically, and we cap it at 25 students. We also have undergraduate peer mentors that are embedded in the co-requisite course to offer additional support. So the students have a faculty member as well as a peer mentor for every class period, and it's solely graded on participation and assignment completion. So the implications of that commingled model, first, it means that the GE Introstat course itself has students with very widely varied educational backgrounds. And so when we implemented the co-recs, we also redesigned our GE course to account for these inequities. So this became a larger project than just building the co-rec. In terms of the co-rec, the complications of the commingled model are that you have students in every co-rec course that can come from multiple sections of the GE course. And so this means the GE course has to be really highly coordinated for this to work well. So we do have course coordinator time allocated for managing all of our GE Introstat and co-requisite courses. And we also schedule our co-recs on Thursdays and Fridays. Our GE courses meet just 2 days a week, and we tell students you should enroll in a co-rec section that's after your two class sessions from your main course so that everybody has seen the same content by the time they get to the co-rec. In terms of who enrolls, in general, any student is allowed to enroll, but we started with the model of directed self-placement, which is similar to what Rebecca was saying, where you can kind of self-assess if you want to be in the co-rec. So for us, we developed a short diagnostic survey to help students determine if they're recommended for the co-rec or not. And we found overall the diagnostic was a really good predictor of if you should enroll or not, but that students overwhelmingly ignored the recommendation. And so when that wasn't working well, a couple years ago, we switched to the multiple measures placement. And so this is really category driven, where the CSU puts students into 4 different groupings based on background information. And I think we have 2 of those lowest groupings where students should be automatically enrolled into the co-rec by our registrar's office. And then again, other students can still self-select. The 3 components, Roxy really mentioned that co-requisite math knowledge piece. So we have the math knowledge, the general support for course content, as well as study skill development. And for us, this shows itself in the class as mostly group work, group activities, and worksheets. There will be mini lectures by the professor. We have special presentations on study skills, and then time to do exam corrections or open homework work time as well. This is an example of co-requisite math content, and I want to give a little context here because I think this is one of the most common questions of like, I'm a statistician, what do I do to teach math? So like Rebecca noted, we also have this focus on embedded just-in-time math skill development, just for what you need for intro stat. For us, we use all open source materials for our classes. So we use Intro to Modern Statistics through the Open Intro sequence of books, and there's no co-rec book that goes with that. And so we've developed all of our own co-rec materials just based on that kind of backwards mapping, like Roxy mentioned, for what we need for the specific topic. We did try using an adaptive online modules for remedial math skills and just found that it was too much. Students didn't need all of that. They really just needed this embedded just-in-time approach. So from there, that example was, the equation of a line. Then after that, they would immediately follow up with, okay, let's translate this into regression. What does this look like for your statistics content? And then they'll have time to practice that in the context of statistics. For study skills development, we do a lot of different workshops. Like I said, we start on the first day by having them talk about an article that talks about why we don't say I'm bad at math. Our counseling center gives a test anxiety workshop, and the faculty will lead other workshops or special topics as well. A little bit of data, you've heard some of the national data, so this is specific to CSUMB. We found that when we implemented co-recs, which was also when we redesigned the class, keep that in mind, that our overall pass rates improved for all students. You'll note this data ends at spring 2020 because then everything changed. But for a little bit of the historical context, under the remediation model, how did students do in their intro stat class? So if you had to go through remediation, you only had a 50% or 58% success rate in intro stat. If you never needed remediation, 79% of those students were passing. So we had an equity gap where, as we've noted, remediation didn't really help you get through intro stat. And then when we moved to the co-requisite model, we basically eliminated that equity gap, and students taking the co-rec are passing at the same rate as students not taking the co-rec. We also looked at other equity gaps. This is just one example. Rebecca talked about the racial equity gaps, how we saw the gaps are still there in her second graph, but everybody's doing better. And that's what we're finding as well, is that we're improving overall with the co-requisite model, students' ability to pass the class, and we're not leaving anyone behind. Our most vulnerable students are also improving. I want to be very honest about the challenges though, so that we don't just make this sound simple. I understand why many people haven't implemented yet because it's a lot to put together. So COVID has been a huge challenge for us in terms of it feels like almost all the progress we made was wiped out. And so we're back to seeing high DFW rates and needing to figure out how to address modern student concerns. Enrolling students is really challenging. I find that the students who need the co-rec the most are often the least likely to enroll. And even if we force them to enroll by our procedures, they can also drop before the class even starts. So they're not really forced to take the class. And then we also find with this commingled model and having a separate co-rec course, students will often just stop attending the co-rec partway through the semester. So we have attendance problems that happen with getting students to continually get the support they need. This also requires really strong administrative support. So you have to have the backing of the registrar's office for that block enrollment. Advising needs to have certain messaging about the co-rec and all the other administrative pieces to put this in place. And it was a really big investment to get started. We had extensive professional development and financial support from the chancellor's office. But even with that, it was very intensive, and the timeline was tough. So all that to say, there's many challenges, but again, the benefits for us have far outweighed, and it was a move that we're glad we made. So our next speaker will give a lot more context for how this administrative support can work. Thank you.
Thanks, Alana. Thank you, everyone. So I want to talk a little bit, and I don't have any slides, so if you're not seeing slides, don't panic. I want to talk a little bit about and highlight the importance of centralized academic services and the role that they can play in supporting the work that's going on in these co-requisites courses and really extending what's going on in the co-requisite courses. And that's because a lot of what happens in places like Learning Resources Center or tutoring centers that you might have on campus is very similar to what happens in the co-requisite sections. So one of the other things I'm going to emphasize as well is the importance that students definitely master the content of their co-requisite course and the main course that they're taking, as well as learn how to be effective learners. And I think in Alana's presentation, she showed that having study skills as part of a section is a common model, a common part of how co-requisite works. But I want to emphasize a little bit that it's important to include not only just study skills, but also important non-cognitive skills like growth mindset and self-efficacy. And Alana, it sounds like you do incorporate that when you address that issue of like, I'm just not good at math. That's part of growth mindset. And that's important for students to hear as well, so they can persevere and get through your class. So we've heard a couple of great examples of co-requisite course models in statistics on different campuses. Then co-requisite courses commonly reinforce the content of the primary class and provide refresher lessons on core concepts and skills, provide opportunities for practice and application, and provide lessons in supporting better study skills. Now, faculty members who teach these courses and the co-requisites often feel as though they need to take on the entire burden of helping students to be successful in these courses. And I just really want to suggest that faculty should recognize the important partners that they have working in these centralized academic units. Many of these folks who are really willing and happy to help you and really willing to make close connections with faculty member to make sure that the content of what they're doing in their learning centers works for faculty and what they want to achieve in their classrooms. And so places like Learning Resources Center also provide refreshers of core concepts, offer opportunities for practice and application, and help students to learn how to be learners. So they're doing all of those similar kinds of things. So let me give you just a couple of quick examples of how we've done this at CU Denver. The first example is our boost sessions, which boost sessions are intensive 3-hour sessions that are held around the beginning of the semester. So either just before the semester begins or in that first week. And they're designed to prepare students who are enrolled in classes that are traditionally difficult for many students. So things like statistics. So boost sessions provide that refresher before the semester even begins and bring students up to speed on core knowledge and important classes. Now, at CU Denver, we rely a lot in our Learning Resources Center on peer educators. So peer tutors are really the core of the people that we work with. But our peer tutors are all trained by faculty and LRC staff. Our math boost sessions, for example, cover everything from very basic math, decimals and fractions, to much more complicated stuff as well. And those sessions are offered online to students, and they help those students to hit the ground running. So those might be available to you. So tutoring, we all know the importance of practice in mastering content and skills. And students might be practicing in their co-requisite section. I think it was Rebecca say when we met for our planning session that, some co-requisite models have that co-requisite credit, or the time in that co-requisite session is mainly spent on just practicing. You can extend that by extending that into formalized tutoring if you have a learning resources center. And at the Learning Resources Center at CU Denver, we have established tutoring tables that exist every day. So we've got little flags on the tables, and it says math tutoring here and chemistry tutoring over here. Those tables are led by a peer tutor, and we provide snacks and soda and a really welcoming environment. So in our Learning Resources Center, our Learning Hub, it becomes really active and bubbly, especially after classes get out and students are moving into their tutoring and practicing session. We strategically schedule our open table times to coincide with the end of certain math classes. We go in and we recruit students and make sure faculty are available for it, that faculty are aware that the tables are available. And we find that sort of gaggles of students from these classes are coming in, sitting at these tables, socializing while also practicing together after their section. So this has worked really well for us. And my last example of how the LRC, our Learning Resources Center, worked directly with faculty teaching co-requisite courses to embed important lessons on growth mindset and self-efficacy into that co-requisite. And this is a math class, but it's Math for the Liberal Arts, is where we did a pilot with Math for the Liberal Arts. Now, we felt that incorporating growth mindset into a math class was particularly important because it would encourage students to embrace challenges and setbacks as opportunities for growth. And we also felt like it would help to break them up. I'm not good at math. I'm just not naturally good at math. So we really wanted to embed those kinds of lessons in the co-requisite class, which it hadn't been up to this point. So we hope that this would reinforce a positive outlook and foster resilience for persistence and as students tackled this content. So for self-efficacy, which we define as the belief in one's ability to succeed, which is a critical factor in student achievement, we incorporated activities and discussions that build self-efficacy. So things just like knowing who to reach out to. It's okay to talk to your faculty member. It's okay to go to the Learning Resources Center. These are the things that you can tap into if you're having trouble. So we worked directly with faculty to insert this content and to teach the content on growth mindset and self-efficacy. This content specifically, though, was delivered by a peer educator, a peer tutor, which worked well for us. So our data and finding on that is we did a pre and post survey using the Stanford University Spark instruments. And our data indicates important increases in the growth mindset and self-efficacy. So for self-efficacy, we saw a 6.7% increase in students self-reporting that a belief in their ability to achieve and to go on. And for growth mindset, we saw a 34% increase in students reported aspects of growth mindset that they were expressing that they had kind of adopted this growth mindset. So the last thing that we measured in changes for students was a sense of belonging. And we did this because we know that if a student is experiencing struggles in a class, it's very easy for them to check out and to say, I don't think I belong in college, especially our students, most of whom are first generation college students. They say, maybe I just don't belong. And so we measured a sense of belonging as well. And we saw a 7% increase in sense of belonging between the beginning of the semester and end of the semester when students were given the opportunity to feel like they could do math, they could succeed in it. So I just want to emphasize that you have these partners who want to work with you. They're happy to work with you. And I know that faculty working so hard and like doing these courses and really supporting students in ways that are very labor intensive. I just would encourage you to tap into your Learning Resources Center because the professionals who work there and the students who work in your Learning Resources Center want to help you with the work that you are already doing.
Thank you so much. And thank you to Donna and our panelists who have already been answering some questions in the Q&A there. We'll just go straight to the remaining questions there. So my friend Brooke Buckley actually has the same questions that I had posed, that I know that our panelists had said maybe they didn't have a lot of experience with these co-requisite courses in the online setting, but I'll throw the question to them, and then I'm also going to say, hey, to the audience, if you have suggestions for this one, please put those in the chat. What suggestions can you offer for providing co-requisite support in online course offerings?
Yeah, so I can say for us, we don't teach any online right now. We did teach it online during COVID, and we moved away from that because it was hard. So in terms of what has been really important for our students being successful in the co-requisite has been group work and the pace and the time to work out their thoughts with people that they feel comfortable sitting next to, just struggling and thinking through something. So we tried to translate that into online also, which is really hard because we were putting students in breakout rooms and having them work on things together, and getting students to do that is really challenging. So if this is a totally asynchronous online, I don't have experience with that. In terms of if it's online and you have some synchronous time, I would try to find ways to still build in that collaborative work experience, because I think that's one of the foundational parts of this working well.
I think, and this kind of ties in with another question I tried to answer in the Q&A that was online. I think it depends on if the online course is synchronous or asynchronous. With the asynchronous, I think the big challenge is it's hard enough for them to put in the 4-unit time online, right? And then these extra, it's really hard to monitor that. One thing that we try to do is in the Canvas shell for the CoRec course, that's where we have all of the assignments that are focused mostly on those supportive skills, like how to study, how to do note taking, how to do test prep, how to learn from the test you just took, that kind of thing. So putting those kinds of assignments in the CoRec online course, I think would be important. But really, I think as instructors, we all know part of it is just having more time, to engage with the material and to talk about the material. And, that is always challenging in any course to schedule in an online environment.
Thank you. I'll add that we're currently in the process of redesigning our online course. And so I don't necessarily have solutions, but I can help identify, I think, some of the issues we've seen. I think at least one of the instructors of the online course noticed that it seemed like some of these students, many of whom have, jobs and families that they're taking care of, and they may have felt like some of the work was busy work. So, I think one of the things we're going to try to do is pare things down and really focus on what's essential, in that support course. I think that's going to be really important. And as some of the others have noted, just trying to keep them engaged and make sure they're interacting with each other somehow, whether it's through discussion boards or, something like that, I think is important too. All right. Lauren is asking, Alana, you mentioned both math content and study skills in your course. How much time do you allocate to each? My university would like me to have both in my co-rec that I'm developing for my intro stats course, but I only have one 50-minute co-rec a week. Struggling to figure out how to balance both these expectations.
Yeah, we've tried a couple different things. The model that we use right now is really that it's the study skills piece is only once in a while. So every couple weeks, there might be a special workshop that we do, or, hey, today we're spending 20 minutes on time management, or today we're spending the first 20 minutes on the I'm bad at math article, or something like that. And then it's not really peppered into every class period. In the past, we've had little asynchronous discussion boards posts that students would need to do on different student success skills. I'll have to remember, I'll add it to my slides. There's a book that we use that's something like 32 topics that all first-gen students should learn about college or something to be successful. And we built in one of those for every week, where they had a discussion board, and then we discuss it for like 10 minutes at the beginning of class. So that's another way to make it take less time. In terms of the math skills piece, since we've moved to this kind of just-in-time setup where it's not this separate online adaptive learning thing where we really treat it as something different, when it's really embedded with the material, I actually don't even really notice it as seeming like different time, because the skills are helping them with the stat skills too. So it might be just the first couple questions of the stat content worksheet are kind of math prep material so that they're successful in the stat content, but it's really embedded. And so maybe it's, I don't know, a fifth to a quarter of what they spend their time on, relative to, it's more time on the stats, but on the stats part, they're still practicing the math, right? So it really is this embedded component that I think can flow really nicely if you're doing the just in time.
Thank you. Let's see, someone asked, Margaret, I would love to see the syllabus or any similar information about the Boost course for an intro stats course. Is there a web page?
You can look in the Learning Resources Center, University of Colorado, Denver. There should be a webpage on Boost, but I don't think it's very detailed. But if you want to send me your email address, I can send you any material that we have. Happy to do it.
Great, thank you. Next question. From all of the models being described, it sounds like a very centralized approach to things like course structures and section scheduling is required, as well as a lot of upfront funds and admin support. Are there ways to get co-rec supports going in a decentralized system and on a shoestring budget? Easy question.
Ours is super decentralized because we don't have any support from our other offices necessarily. For us, it was just a matter of getting through curriculum committee, the increase in units for our intro stats course, and the co-requisite support. Once that was in, and once we put in the schedule, then we were off and running, because students self-place. We don't force anyone to or mass enroll anyone, so we don't need to work with our administrative services on that part. And we collaborate within the department on, hey, what are you doing in your 10C section? So and there was no budget, so that was our shoestring. But I'm not sure if that answers your question or not.
I would just add that I would go with Rebecca's model and make it cohorted and not commingled, because commingled does take a lot of at least departmental coordination, in terms of, again, the sections being kind of uniform, so any co-rec can work for any section. And I do think no matter what, though, there's that piece, like Rebecca, you said, the counselors are recommending students to take the co-rec. So there's always going to be some piece of, if your university wants it to be successful, I think it's worth pushing back and saying, do you want this to work? You have to at least talk to advising. Like, advising at least has to have things figured out for how they're going to talk about the support course to students, so that it sounds like something useful, not just another burden.
And we actually, because I am at a two-year college, which is quite different, much smaller, of course. We actually, when it was difficult to communicate our vision to our counseling advising group, we just started going to the advising sessions ourselves and making this sound like the most awesome experience a student could have if they were feeling at all nervous about, taking statistics, or they'd heard stories and it made them a little nervous. We just went to the orientation sessions ourselves and tried to make this appear like the most wonderful experience they could have if they were going to take, while they were taking a great course to begin with. So we kind of took that on ourselves to promote the course, because it really is, you are depending on someone else to sell your course and to get your enrollment. And it's something we know that students value, because what we found often was, students would get the message of, well, there is this course, but you don't need it. Well, yeah, they kind of did, so and similarly with tutoring, whenever our department was such that if we were having, challenges, or we thought we could, give a different message, then we just kind of took that on ourselves. But again, I'm at a small 2-year college and we could do that.
Okay, I think I'm going to lump a couple of questions here together. Raymond says, this sounds great. What happens to students who change majors and then need a math class that needs more math or algebra? And then Josh Sparks asks, so say that students soar through their statistics class and wish to take more statistics courses or other science courses that require more of an algebra knowledge base. How do we advertise that transition to college algebra and beyond, whether we continue to push co-rec support for students when they take college algebra? Maybe put those together.
California has a new experiment in that now they are mandating this for STEM courses as well. So we are no longer able at a community college or 2-year college to offer courses leading up to calculus. So now we are developing co-requisite models for calculus. So I know some of you are thinking how the intermediate algebra, pre-calculus, and it's like, yeah, we're not offering pre-calculus anymore. It's an adventure. You know, I think the model, and again, it's in development, and you know, it worked great in statistics, and people who are strong proponents for it in statistics are still like having deep anxiety about how this is going to play out with calculus. You know, I think the model is like, so someone, and I've had this experience, they take intro stats, they have a wonderful experience of like, I'd like to study more of this. And you like, okay, well, calculus, I guess, you know, because statistics majors require that. I think, again, then to look at this co-rec model for calculus. And I think the dream is that eventually the majors at the 4-year schools would develop, like really consider, do statistics majors really need all of calculus? Could there be, just like we have business calc, could there be calculus for data science and statistics majors, which are, you know, that's a population that's growing and growing faster and faster. So as always, we at the 2-year colleges just hope that eventually there would be these changes in curriculum at the 4-year level.
And I would say that at places that do still offer college algebra, it is common now to see college algebra with support. And so a student that wanted to change pathways and now required college algebra could go in directly to a college algebra course and get the math they needed for that course as part of a co-requisite. So I don't think it blocks pathways. And we've known that if students decide to change majors along the way, they often have to backtrack a little bit and do additional work, not just in mathematics. So I think as this co-requisite model is growing, you'll see that happen. I mean, the AMATIC statement recommends it for all basically entry-level mathematics courses. So that would be statistics, quantitative reasoning, college algebra, calculus as well.
I don't know how long our panelists can stay. We have a couple more questions. Jennifer asks, how have colleges navigated the pay to faculty members if a faculty member teaches the co-rec class? For example, 3 5-credit classes is full-time, but as the class is now 6 credits, scheduling pay is trickier.
I'm hoping that Margaret has good things to say. Being in administration, I can just speak to my experience, which is this has become increasingly more complicated. I don't have an answer for you, but when I started, it was, oh, you have a 12-unit load and it's all classes are 4 units. So it's really easy. You have 3 classes. And now all of our GE classes also got mandated to move to 3 units. And then our co-rec, that's a 1-unit activity period, but since it's 2 hours, faculty get 1.3 units for it. So my schedule never adds up to 12 units anymore. And it's a constant like negotiation with the dean of, I'm going to be under this semester. So next semester, maybe I'll go over a third. And it's never really clean, but we're really paid by the unit, our lecturers also. And it's a balancing act with the administration is what I found.
I can tell you that our course, the co-requisite course, it's 1 credit for students, but it's actually 2 credits for faculty. And we have one of our introductory statistics courses that is 4 credit hours. And we also have calculus that's 4 credit hours. There may be some others. So usually I think what happens is, faculty will kind of pair up that 2 credit hour with, say, like an intro stat that's worth 4 or something like that to make things come out nice. Our end asks, is there a model where the co-req materials are embedded in the course material and students simply self-select to work on the materials they are struggling with? Interesting. Though I am hearing it sounds like it is important that the co-req materials be directly covered.
That's that good old phrase, students don't do optional, right? So if they're available but not necessarily assigned, it's hard to make them have students take advantage of that opportunity. So
Yeah, I generally agree with that. The only thing I can think is an example for in Canvas, you can set it up so the rest of the materials in a module won't show up until you complete the first one. So if you want, you could say, here's a little, pre-math skills assessment, work through this and get to 100% credit before the rest of the content will open. So it would still be kind of forcing students to go through it, but if it doesn't take them much time, they move on. If they need to spend more time on it, they do. So you could do something like that where they spend the amount of time that they need. But I agree in general, if it's optional, it's not happening.
If it's optional, the students that don't need it do it.
That's true, Roxy.
That's a very good point.
however, if we called it extra credit, now we have another conversation.
I think we've got all the questions in the Q&A. There was a question in the chat about math needed to obtain a statistics degree. I'm going to suggest, James, if you will email me, I would be happy to talk to you about what you need for a statistics degree. I will put, let's see, send this to everyone. I'm going to put my email address in the chat there. Okay, let's see. I'm going to remind our panelists to send their slides to Donna. And I'd like to thank our wonderful, wonderful panelists. This was a great discussion. I appreciate this so much. Does anybody have any parting words before we go?
I'll just say it's hard, but it is worth it. It's been really good for our students. And so go for it.
Yeah, I'll second that.
And I'm
Those are-
sure I don't want to speak for the panelists, but we'd be happy if you have other questions or you need you want to talk about anything as you're trying to discuss do your course. It's easy to find us, so please reach out if we can help you.
Yeah, I'll add my email to the slides before I send them to Donna.
Oh, perfect. All right. Thanks again, and we will see you all later. Bye.
Bye.